Good afternoon. So now we're going to be reviewing some grade 10 topics. And the first topic we have is matter. Okay, now remember now that chemistry studies the composition, behavior, and properties of matter. Okay, but what is matter? Matter is everything around us that has mass and volume. We know that there are three states of matter. The first one is solids. Now, solids, we say they have a definite shape as well as a definite volume. Okay, what does that mean? That means that the shape as well as the volume is fixed. It is not going to be changed. Now, liquids, they have no definite shape, but they have a definite volume, meaning that the shape can be changed, okay, depending on the container that you place it in. Whereas gases has no definite shape nor definite volume, which means that it will take the shape of any container that you place it in and it will spread out evenly within that container. Now we'll talk about compressible states of matter. So here we have liquids and gases that both can be compressed, unlike solids, okay? This means that their volume can be reduced by the application of pressure. And this can happen because liquids and gases, unlike solids, they can move. So we can now use the kinetic theory to talk about the particles of solids, liquids, and gases. So for solids, we can see over here that the particles are really tightly packed. Okay, and the reason for this is because of the forces of attraction, okay, between the particles. Okay, the forces of attraction are really strong between those particles of a solid. Okay, and as a result there is very little movement. Okay, and they can only vibrate, okay, against one another or vibrate in their positions. Okay, now if we look at the particles of a liquid, we can see that the particles are close together but not as close as in a solid. Okay, and they move around in a random way and they often collide with each other, and they have more energy than particles of a solid. Okay, so when it comes to these solids, liquids, and gases, you have to be able to talk about the spacing as well as the movement. Okay, now we will look at the particles of a gas. Okay, now the particles of a gas, they are very far apart, okay, as we can see here, and they are free to move anywhere within the container. They move randomly and they move at very high velocities. Okay, and they move more rapidly than liquids. Okay, and it is important to know that the particles, they move the fastest in this state because they have more energy. Okay, they have more energy, they have more space, so they would move more quickly in this state. And another thing to notice that there are virtually no forces of attraction, okay, between the gas particles, okay, and hence the reason why they are very far apart. So how do we know if a substance is a solid, a liquid, or a gas? So a substance is a solid if the temperature of the environment, if it falls below the melting point of the substance, because we know the melting point is the point at which the substance turns into a liquid. So if it falls below the melting point, that means that substance has to be a solid. But what about a liquid? How do we know if it is a liquid? The substance is a liquid if the temperature of the environment falls between the melting point and the boiling point. Melting point, the substance is a liquid, and the boiling point, the substance is a gas. So if it falls between those two, then the substance has to be a liquid. But how do we know if a substance is a gas? If the substance is a gas if the temperature of the environment, if it falls above the boiling point, because we know the boiling point is the temperature at which the substance changes to a gas. All right, so if that temperature is above that, then we know that it has to be a gas. Okay, so now we're going to work out the state of matter for these different substances. So we have some information I want you to look at very carefully. They give us the melting point, They also give us the boiling point of the substance, and they tell us what temperature we're at. So we are at 20 degrees Celsius, which is room temperature. So at 20 degrees Celsius, nitrogen will nitrogen be a solid, liquid, or gas. The melting point is negative 210, and the boiling point is negative 196. So now we have to predict whether the substances are solid, liquid, and gases based on the information that they give us. So they give us a melting point, the boiling point, and they also tell us that the temperature of the environment is 20 degrees Celsius. So we need to now predict what these substances are going to be. So the temperature of the environment for sodium chloride, the melting point is 801, the boiling point is 1413. So at 20 degrees Celsius, is that substance going to be a solid, liquid, or a gas? It is going to be a solid. And the reason why it is going to be a solid is because this 20 degrees Celsius, okay, is lower than the 801 degrees. So that's why it's going to be a solid. Now bromine, at 20 degrees Celsius, we know that 20 falls between negative 70, negative 7, and 58. So that's telling us that it has to be a liquid. Now iodine, okay, at 20 degrees Celsius is less than 114. So we know that it has to be a solid. Okay. Now, how would we complete this table? So for solids, we talk about how are the particles of a solid arranged. Okay. We can say that they are very close together. Very good. Liquids, we can say that liquids are close together. Gases, we can say that they are very far apart. Attraction forces in a solid, we know that the attraction forces are very strong. Liquids, they are weak, and gases, they are very weak. Okay. What about the shape? Solids have a definite shape, liquids have an indefinite shape, whereas gases have an indefinite shape. What about volume? Good job. Very good. So if you said solids definite, and then you said gases indefinite, you are totally correct. Good job. So now we are going to use the kinetic theory to explain what happens when matter changes from one state to another. So all matter is made up of tiny moving particles, invisible to the naked eye. We cannot see these particles. Different substances, they have different types of particles. So you could have atoms, molecules, or you could have ions. But it's important to know that these particles are always moving. The particles, they gain kinetic energy and move faster when they're heated, and then they lose kinetic energy and move slower when they are cooled. Heavier particles move slower than lighter particles. Okay, that is very, very important. So what exactly happens during melting? So we know that melting is the change of state from a solid to a liquid. We know that the first thing that needs to happen is that the temperature must increase. What is going to be happening next? We know that the kinetic energy of the particles is also going to be increasing, okay, because the particles now have more energy in the form of heat. Next, what's going to happen is eventually the particles are going to have enough kinetic energy to break free of these attractive forces which are keeping them together. Okay, and then at a certain temperature, which is called the melting point, the solid is going to change to a liquid. Okay, and we know that that temperature is called the melting point, and that's the temperature at which that substance melts, and that temperature is 0 degrees Celsius or 32 degrees Fahrenheit. What happens during evaporation using the kinetic theory? So we know that the temperature has to increase. After the temperature increases, we know that the particles are going to be moving faster. After the particles move faster, we know that now some particles at the surface are going to have enough energy to overcome the forces of attraction between themselves and the other particles to form a gas. Okay, the liquid begins to evaporate as the gas is formed. Then, at a temperature called the boiling point, what's going to happen is the particles are going to have enough energy to break the bonds all together, and then the liquid is going to turn into a gas. Okay, so key thing is talk about the temperature, talk about the kinetic energy, talk about the movement of the particles, and then talk about the forces of attraction, and that's it. So what happens during boiling using the kinetic theory? So eventually a temperature is going to be reached at which The particles are trying to escape from the liquid so quickly that bubbles of gas start to form within the liquid. So we saw that evaporation happened at the surface. Now the boiling, when you boil something, you would notice that bubbles are going to be forming within the liquid. And this is going to happen at a temperature known as the boiling point. Okay? What's the difference between evaporation and boiling? So evaporation occurs at any temperature. It happens slowly, as well as it happens at the surface. On the other hand, boiling will happen only at the boiling point. When the liquid temperature is high enough, you're going to see bubbles being formed throughout the liquid. So evaporation, bubbles will be forming at the surface, whereas boiling, the bubbles will be forming throughout the liquid. Boiling will only happen at the boiling point. Evaporation can occur at any temperature. Sublimation now is a change of state from a solid directly to a gas. And an example of this is dry ice. Another example is iodine.